Let's talk about the Artemis program. The Artemis program is quite possibly the single most convoluted program that NASA has ever derived. In a nutshell, the goal of the Artemis program is to send humans to the moon and to build some kind of a station, most likely on the south pole of the moon. Although there's a huge facet around it. It has been around in some form or another since 2004. During the Bush administration, they set plans to send humans to the moon. The exact details have changed a couple of times over the years, but the goal remains the same: to land humans on the moon and, as a stepping stone, use that to get towards the planet Mars. The pieces of the program that we're going to talk about are the Commercial Payload Lunar Services program, Orion, SLS, Human Landing Services, Gateway, and we're going to talk about some of the other technologies that are associated as well. As I mentioned, this is an extremely complex program. But let's start at the top. The Commercial Payload Lunar Services is basically an extension of the very successful resupply missions towards the ISS. The idea is that instead of designing the lander to land on the moon and having a custom built thing every time, that NASA would instead pay a commercial company to build their lander. They could be one of many payloads on there, and they could land something on the south pole of the moon. I recently talked about a commercial latch on to this program that will send race cars around the surface of the moon in a previous video. This is a really, really neat program, and it's a way to save NASA money. They can land this rocket on the moon. They can have all of their payloads that they need to figure out the different kinds of things that they need to test out, the Artemis program, maybe even send supplies on one of these. But at the same time, they can have a commercial aspect, which will reduce the cost. And it's a pretty neat program. They have contracted with, I think, 9 different providers to potentially offer services. They have firm contracts with 2 of them, Astrobotics with their Perigene lander and Intuitive Machines with their Nova C lander. Those 2 are going to be hopefully launched sometime in 2021, although the way that missions go, it may be in 2022 when this finally happens. Those are kind of a test bed of things to come in the future. They may have another landing opportunity, or they may provide some of the other companies that are also trying to get some kind of a landing in there. But this whole thing is just a really neat program, and I'm really excited to see how it goes. It's kind of a little bit obscure to think about it paying some kind of a payload to land, but it should work out really neat, and hopefully all will go well in the end. I'm not really sure how all of this is going to be used, but these will be the first landings from the United States on the surface of the moon in many, many years. It should be really cool, and it's a really neat concept. It's similar to the Red Dragon mission that SpaceX was going to land something on Mars. Presumably the same thing will work on the moon too. Next, let's talk about the oldest of these that is under development under the same contract, and that is the Orion mission. Orion is a Apollo on steroids. It's basically the Apollo command capsule, but much bigger. It could theoretically hold 7 people if you were just bringing it to, say, the International Space Station, which it could theoretically do. I don't think it's ever going to practically do that, but you never know how these things are going to turn out. Its main mission towards the moon, it can carry 4 astronauts, which is enormous. We'll be able to supply them for some period of time. While the capsule is much bigger than the Apollo program, the service module is actually smaller. And as a result, it doesn't have the amount of delta V that the Apollo missions were capable of. The Apollo missions could directly orbit the lunar surface in a lone lunar orbit. Orion doesn't have enough fuel to be able to do that and to get back, so it will have to be in a higher lunar orbit, which we'll talk about later when we get to the Gateway program. But still, it's a very neat capsule. It's able to return from an interplanetary trajectory and land in the Earth. It's only been flown once in 2014. It was done as a test on a Delta Heavy rocket. Delta Heavy was the only rocket on Earth that could possibly lift it into that kind of an orbit. Orion is actually a pretty neat little vehicle, although It's gotten a lot of grief. It's cost far, far more, and it hasn't really flown, but it's more or less ready to go. The biggest thing it's been waiting for is a rocket that's capable of lifting it into these kinds of orbits. In theory, you could launch on a Falcon Heavy. There was some talk of a Frankenstein rocket where you take a Falcon Heavy rocket, have it launch the upper stage of the Delta rocket, which is actually similar to the upper stage of the SLS rocket, which is going to launch it, and put the Orion capsule on top of there. This Frankenstein rocket could theoretically be launched into a low Earth orbit, and then the upper stage could kick it off towards the moon. And from there, it could perform its mission similar to SLS. The price tag would be much, much less than a single SLS rocket, which, as we'll talk about, is in the billions of dollars. I'm sure for this one-off mission, you would still be talking about maybe $500 million, but still, that's peanuts compared to the crazy, crazy amount that SLS is going to cost. Speaking of SLS, let's talk about that more. The SLS, or Space Launch System, or as some people like to jokingly call it, the Senate Launch System, was created inside of the Senate. This is not something that NASA really had a whole lot of say. And it kind of takes a Kerbal Space Program approach to rocketry design. And I'm not talking about the expendable boosters and everything type of things that are lots of fun. I'm talking about the idea of putting a tank together and putting some engines on and making it go. The idea was you take a bunch of the shuttle hardware and you do some slight modifications to it, and you can have it actually a workable rocket. And it should be much cheaper because you have existing parts. That should be great, right? The problem with the SLS rocket, though, is they're trying to reuse the shuttle hardware, which was purposely designed for a specific mission, with reusable engines, with the shuttle off to the side of the big giant booster. And by so doing, it turns out that the mission's a lot more complex than you would think. They have to totally change the way that the weight is distributed on the tank. And that basically means redesigning the entire thing. If they were redesigning entirely from scratch, then they could really do a much better job. But because they're limited to this, then they actually are finding it far more expensive. This is what happens when politicians design rockets. It just doesn't go that well. And the SLS program among the space community is tremendously unpopular as a result. Although, in fairness, I have to say that the SLS rocket is an extremely capable rocket. Not any rocket in design, with the exception of Starship, has the capability that this has. And Starship only has that capability if it's able to be fully reused and is able to be refueled on orbit. Otherwise, it still falls short of the capability of the SLS rocket. That being said, even a single launch is expected to cost around $1.5 billion. Huge sums of money. You could launch 10 Falcon Heavy rockets in their fully expendable configuration for that cost. My personal feeling is that SLS is great for the human exploration things. It's the only rocket that can actually carry the Orion capsule into a translunar orbit directly. Although the Frankenstein rocket of the Falcon Heavy with the upper stage of the Delta Heavy could theoretically do it, you still have to do a lot of redesign to make that work. But overall, it's a pretty neat little rocket, way, way too expensive, but very capable. I think that they should use a Falcon Heavy for a mission like the Europa Clipper, which is currently tagged to only use for the SLS rocket, and that mission will go to the moon of Jupiter, which is very interesting, Europa, that has a possible subterranean ocean. SLS can carry the widest payload of any currently existing rocket. It could actually carry pretty much any of the big telescopes in the world directly into orbit, which is absolutely insane. Starship will be able to do that, and I actually trust that Starship will be able to do that kind of mission without any of the crazy reusability that they have to demonstrate otherwise. So it's entirely possible to carry a large telescope on Starship in the next few years without any of the really advanced technology being played out that they need to work. Slightly less controversial, but still highly controversial, is the Gateway space station. The Gateway Space Station, LOPG, the Lunar Orbiting Platform Gateway, as it is formally called, but most people just call it Gateway, is basically a space station that is in a highly elliptical orbit around the moon. It's in a very special orbit called a halo orbit that has some really neat qualifications that allow it to stay put. It doesn't need a lot of fuel, and actually keeping a spacecraft in orbit around the moon is surprisingly difficult because of the unevenness of it. It has some very high gravitational regions relatively, which will tend to make something unstable. It will pass very close to the northern pole of the moon, and it will be a kind of platform for scientific studies. This actually has a lot of potential to study things that are outside of the magnetosphere of Earth in a regular basis. So there is a lot of science that could potentially benefit from there. It, like the International Space Station, will have the ability to operate more or less autonomously, doing lots of science experiments that are controlled by controllers on Earth, while at the same time allowing for habitation. Although, unlike the ISS, the Gateway will largely be uninhabited. It will be only inhabited for brief periods of time when a lunar mission is underway, most likely. There will be a number of docking ports, and the Orion capsule will come and dock with LOPG. A landing system to land on the moon called the Human Landing System, very creatively, will also be docked, and they will exchange the astronauts between them. They may stay there for a few days until they get to the right spot, and from there they can relatively easily land on the surface of the moon. It is a kind of neat little concept, although having an entire space station for what amounts to a transfer seems a little bit strange. And in fact, the first landing missions onto the surface of the moon won't even take advantage of the orbiting gateway. They will just meet an Orion in deep space and be able to make things work from there. Still, in the end, it will most likely make going to the moon a little bit easier. It's a gateway, as it is intended to do that. It will provide some fuel and perhaps even a tug that will take the spacecraft to a lower lunar orbit. This tug could be an ion engine that can be reused. One of the cool things with Gateway is it's expected to have a fuel depot, which would allow you to reuse at least a portion of the spacecraft to be able to make all of this work. And while it does very much seem like a space station in need of a mission, it does have some potential there. My personal favorite part, though, of the Artemis program is the most recently announced one, which is the Human Landing System, HLS. And they're doing this part of it right. Pretty much everything else that they've done is the traditional NASA way of approaching things, where NASA designs it. They send these designs out to contractors. The contractors go out and build the spacecraft. They work with NASA to adjust the requirements a little bit, but as a whole, they come up with their system. It's a cost-plus program. The HLS system takes the very successful model of the commercial resupply and the commercial crew missions heading towards the International Space Station and applies it to landing on the moon. They have funded thus far 3 different teams to have some kind of a role on it. The Blue Origin's-led team that's called the National Team, the Dynetics lander, which has a number of smaller contractors that are working together to make it work. And SpaceX is also building their own thing that will be launched. It's really a Starship, although a somewhat custom variant of it specific to landing on the surface of the moon. Starship is a little bit different than the other two. The other two are very, very similar. Starship has the ability to land far, far more cargo on the surface of the moon than either of those. But it's still really neat that they're taking this approach, and they may use multiple of these. The kind of smart money from the beginning is that the Blue Origin's national team, which is largely consisting of the big contractors, the Lockheed Martins of the world, will work together, and they're most likely going to win the first stage, although we have yet to say. Starship, if and when it shows its promise, though, will be able to really exceed everything else that's coming. And as a result, it may be the long-term mission towards getting this habitation on the south pole of the moon, as is the whole goal of the Artemis program. Dynetics is also a very neat lander. It is actually the most reusable of all of them. The only thing that it does is ditches a few fuel tanks that can be pretty easily carried up into orbit. Which one of these wins out? I don't really know for sure. And it's really neat that we have this competition. I love this new philosophy that NASA is doing. It is absolutely wonderful, and I hope they continue to see it work throughout time. There are some other things that are also a part of the Artemis program. The new spacesuits that have been developed for some time. The spacesuits that the Apollo program used had some very serious problems, as do the spacesuits that NASA uses now on the International Space Station. They're really hard to move. They just don't work that well. And so they've been working on a new generation of spacesuit, and they're actually studying the way that medieval armor moves to be able to make it move better. You know, medieval armor had a similar thing. You have to offer protection, but still have a lot of flexibility. And so they're looking at the way this medieval armor moves, and the joints especially, and they're trying to use that as a means to offer protection, but also flexibility. The suits look like something out of the Astroneer space game. They're really kind of wacky, but they do offer full visibility in all directions, and they are pretty neat. In my opinion, spacesuits are another one of the high points of the whole program. These suits will work on the moon, and they should also work reasonably well on Mars. And we really do need a new generation of spacesuits. This is one thing I'm certain that SpaceX will use if they have their plans to go to Mars. No doubt. It just makes perfect sense. They don't want to do everything. They want to be the transportation. There are a number of other things. There are some tugs that will take the spacecraft from the gateway to low lunar orbit, because if they can reuse these tugs, then it'll just work better. The gateway has a number of different proposed modules. As I said, it will be able to refuel things. It's using technology that is very much based off of the commercial cargo. One of the main modules in the gateway will basically be an expanded Cygnus spacecraft. It will be resupplied by a variant of the Dragon spacecraft that SpaceX is using, although it doesn't really bear a whole lot of representation to the Dragon because you can't actually land it back on Earth. It's called the Dragon XL, but really it's kind of a separate spacecraft. It probably has a lot of avionics that's similar, but there again, you can't land it on Earth. Overall, though, it's a really neat program, and while it definitely has its problems, it's way too complex. Getting humans back to the moon is a very worthy goal, and I hope to see that happen soon. I remember when I was in 3rd grade and trying to figure out, when are we going to have a base on the moon? When are we going to have a base on Mars? And I remember reading all these books. I remember the year 2025 stuck out. I thought, oh, cool, this is going to be so exciting. Well, it's 2021 almost. I don't think we're going to have a base on either one of those planets by then, although it could happen theoretically. But it's really exciting to see some progress finally being made towards that. Thank you guys for all of your support, for liking and subscribing these videos, to my Patreons who help to fund everything, to just every one of you who watches this videos. You guys are amazing. Until next time, keep on tracking. Take care, guys.